In this video, we'll graph these two rational functions, starting from the first one, f of x. Well, first let's find the domain. Well, for domain, we'll look at the denominator. Right, so whatever makes the denominator 0 will be excluded from the whole number line. So the domain will be all real numbers but -6. As we can say, it's from -infinity to -6 union from -6 to infinity. That's the domain. Okay, so now let's see, second is this f in lowest terms. So how do we find out if f is in lowest terms? We have to factor function f, especially the top part. It looks like it could be factored. Right, so to factor the top part, since the leading coefficient is 1, so if it is factorable, it will be in this form. So we need two numbers multiplied to be -30 and add up to be +1. So it will be +6 and -5. Okay, over x plus 6. So yes, it's no, it's not in lowest terms. Right? We can cancel out an x plus 6 from the numerator and the denominator. So we can kind of simplify it to x minus 5 under the condition that x cannot be equal to -6. Okay, so is it in lowest terms? No. Alright, so we turn into lowest terms now. So this function turned into y equals x minus 5 with a hole in it, which is at -6. So y equals x minus 5 is actually a line. Right? So this graph is basically a line with a hole in it. Where is the line? What is the line? It's with y-intercept of -5. So let's say -5 is over here. So you have a y-intercept of -5, and the slope is 1. Right, the slope is 1. You can see it as 1 over 1. So up 1 over 1, you have your second point. You connect the 2 points, you have your line. But don't forget, it's under the condition that x cannot be equal to -6. So say over here is -6. That means there is a hole when x is equal to -6. So the graph of it is a line with a hole at -6. Or you can say -6, -6. Okay, that's for C. Now let's look at D, this function. Okay, to find the domain, we need to factor. Well, since we have to factor anyway, let's factor the top and factor the bottom. So to factor the top, 8x squared plus 26x plus 15, I'll factor the a and c. So 2 times 4, or you can see it as 2x times 4x. And to factor this 15, I'll do 3 times 5. 3 times 5, does it work? This is a 10, this is a 12, it doesn't work. Let me change the order. So 5 goes on top. And 3 goes at the bottom. Let's try it again. So cross multiply, that's a 6x, and this way is a 20x. And we need 26x in the middle. Perfect. Check over here, they multiply to be a +15. Alright, this is the right combination. So we can factor the top as 2x plus 5, and factor the second factor is 4x plus 3, right, coming from the first line and the second line. Alright, now let's factor the bottom, 2x squared minus x minus 15, factor a and c. So a is 2 times 1, c is 3 times 5. Let's try it this way first. I don't think it works. So this is a 10, this is a 3. We need a -1 in the middle. Let's switch it around. So 5 goes on top, and 3 goes on top at the bottom. So 5, 3. So 2 times 3 is a 6. 5 times 1 is a 5. We need -1 in the middle. So trace it back. That means the 6 is negative, right? So 2 times negative 3 is negative. Okay, and check over here. 5 times negative 3 is negative 6. Correct. This is the right combination. That means the bottom could be factored as, first factor coming from the first row, which is 2x plus 5. Second factor coming from the second row, which is 1x minus 3x minus 3. Okay, so first of all, the domain is whatever makes the denominator equal to 0, or the zeros of the denominator. Right, so the domain here, we can say, is all the real numbers but negative 5 over 2 and 3. Right, so I will say it's from negative infinity to negative 5 over 2, union from negative 5 over 2 to 3, union from 3 to infinity. Right, because these two numbers is cutting our whole number line into 3 intervals. Okay, that's the domain. Now, is it in lowest terms? Obviously, it's not in lowest terms, right? They have a common factor of 2x plus 5. So that means this graph will have a hole at x equals negative 5 over 2. Right, there will be a hole there. So we can simplify this function as 4x plus 3 over x minus 3. So we will graph this function instead, but we'll have a hole at negative 5 over 2. Okay. Alright, so next, let's find the intercepts. So starting from x-intercept and its multiplicity. Okay, so for x-intercept, we look at the numerator, we look at the simplified version of the numerator, which is 4x plus 3. So the 0 for the numerator is negative 3 over 4. Or you can say negative 3 over 4 is 0. That will be the x-intercept coming from the numerator. The multiplicity for that is 1, which is odd. And we have 1 y-intercept. How do we find it? We'll make x equal to 0. And so I will make x equal to 0. I will just plug it in here. So you have 4 times 0 plus 3 over 0 minus 3. That will give you 3 over negative 3, which is negative 1. So the y-intercept is 0, negative 1. Okay, so we got the x-intercept, the y-intercept, next vertical asymptote, and its multiplicity. Okay, so the vertical asymptote, we look at the denominator of the simplified, or the lowest term version. So it's x equals 3, and the multiplicity is obviously just 1, which is just odd. Alright, and horizontal asymptote or oblique asymptote. You will look at the degrees of the numerator and the denominator. So if you look at the simplified version, the degree on top is 1, right? The degree of the bottom polynomial is also 1. So since the degrees of the top and the bottom are equal, that means we have a horizontal asymptote, and it is y equals the quotient of the leading coefficient, which is 4 over 1, right? 4 over 1. So, which is 4. So y equals 4 is our horizontal asymptote. And we also want to find out, does our graph, which is f, intersect this horizontal asymptote? Y equals 4. So here we need to solve the system. What is the system? It is, we'll just start with the simplified version. Y equals 4x plus 3 over x minus 3, and the other equation is y equals 4. The two graphs. So let's put them into one system and replace y in the first equation by 4. You will have 4 equals 4x plus 3 over x minus 3. Put a 1 underneath, we can cross multiply. And so we have 4 times x minus 3 equals 4x plus 3. Distribute here, you have 4x minus 12 equals 4x plus 3. And subtract 4x on both sides, you have negative 12 equals 3. This is a false statement, so that means no matter what your x is, these two equations does not have a solution. Right? They don't have a common point. So that means our function f will not intercept the horizontal asymptote y equals 4. Okay, so I think I've gathered enough information here. Now I will start graphing. Okay. So this is my coordinate plane. Alright, so starting with my x-intercept, which is at negative 3 over 4. Okay, so let's say negative 1 is over here, so negative 3 over 4 is kind of over here. Negative 3 over 4, and mark it like this. And the multiplicity for that is odd. Alright, what else? The y-intercept is 0, negative 1. It's right here. It's negative 1. Alright, now the vertical asymptote is x equals 3. So let's see, it's 1, 2, 3. This line. So x equal to 3 is the vertical asymptote, and the multiplicity for it is odd. And now we have a horizontal asymptote, which is y equals 4. Let's say 1, 2, 3, 4. Let's say it's here. So we have a horizontal asymptote, y equals 4. And our graph will not intercept this horizontal asymptote. Alright, so we can start graphing. It's pretty obvious we have to connect these 2 points, the x-intercept and the y-intercept. Right. Okay, since the multiplicity for this x-intercept is odd, that means our graph will pass this x-intercept. Right. So we'll pass it. Since our graph won't intercept our horizontal asymptote y equals 4, so we'll just get closer and closer to it without passing it. Alright, back to this negative 1, the y-intercept. We have to pass it somehow, right? So since we only have one x-intercept, it won't go up. It has to go down. Like this. Alright. Since the multiplicity for this function is odd, that means if one side is going down, the other side of the vertical asymptote will go up. So on the right side it will go up, because on the left side it went down. And we will, since our graph won't pass y equals 4 anymore, we'll just have to closer and closer to it above the horizontal asymptote y equals 4. So this will be our graph. Like this. Alright, I hope you find this video helpful, and I will see you in the next video.